Hello everyone, this is Sumanth. In this video, we'll just try to understand what is Z test. So we are just discussing this statistics from last 5 to 4 videos, right? So we just discussed what is hypothesis testing, like what is p-value, what is this null hypothesis, what is alternate hypothesis, and also we've just seen what is normal distribution and standard normal distribution as well. So in this specific video, we will just try to understand what is Z test. So if you just watch my previous video on standard normal distribution, so we have just converted the normal distribution to standard normal distribution, right? So we just call it as when we just converted that to standard normal distribution, we have called it as Z score, right? So we just discussed all the things, the Z score, etc. in that video. So make sure to watch that video first. So before going to this video, like the standard normal distribution video, so that it will be easy for you to understand this Z test. With that, so make sure to subscribe to the channel if you haven't yet, and as well as like this video, Z test. So before going to the Z test, we just want to discuss what is Z score. So I have already discussed that in standard normal distribution video, but for this specific video, we will just try to revise that. So if we just take this as normal distribution, right, the bell curve, and we used to have the points, let's take x1, x2, x3 and x4. So let's take these 4 points in normal distribution. So when you just convert this normal distribution to standard normal distribution, we used to subtract it. So we used to subtract each point by their mean and divide it by standard deviation, right? For example, let's take for x1, we used to subtract x1 minus mu divided by sigma. Similarly for all the other points. So this is called as Z score, right? For this x1, this is the Z score. Similarly for x2, this x2 minus mu by sigma, that's the Z score. So that's about the Z score. So I hope you got it, the Z score. Now let's try to understand why, like when we have to use this Z test. So for that, you just have a population, and in that population you have taken a sample to test the population, and similarly you have taken the other sample. Now if you just want to compare the means of these two samples, right? For example, let's take mu1 is the mean of first sample and mu2 is the mean of the second sample. So if you want to compare both the means, whether the both means are equal, then we will just use Z test. I hope you got it, like when we should use the Z test, right? When you want to compare the means of the samples. So, and the other case, the second case is the sample should be greater than 30. In this population, let's take this example as well. So let's take this, the population, right? So when you're just sampling that, I just said that this is sample 1 and this is sample 2. So to perform the Z test, your sample size, what you just taken the sample here, the sample size should be greater than 30. For example, let's say if you just want to find the average height of in a village, right, the average height of people in a village, then so in each sample there should be more than 30 people. Only then this Z test will be applicable. So just remember these 2 points, like when we should use the Z test. And now let's try to solve a real world use case, so that you can able to so that you can able to relate, right? So that you can able to relate, like when we should use the Z test. So how we should perform the Z test, right? Let's try to understand with an example. Stay with me, like we will make sure to watch this video till the end. We will just try to understand it. So let's take this example. I just have a friend. So this is just an example. So I have a friend, right? So he's having a laptop shop. So he just want to buy around 500 laptops for his for his shop, right? To sell the laptops, he just want to buy around 500 laptops in wholesale, right? Our friend A, he just want to buy 500 laptops. So what he did is, he just went to, let's say, Dell. He just went to Dell company and he just asked them, so I just want 500 laptops, just give me around 500 laptops, he just asked. And they said that, right? The company, the official, they said that, so we are ready to give you the laptops, and the average battery life of each laptop is 18 hours. So they just said that average battery life is mu is 18 hours, right? So my friend thought that okay, they just said that average battery life is 18 hours. So if you just charge once, it's gonna last for 18 hours. That's fine. Let's try to test it. So let's try to test it. If it's okay, if the what they are saying, what they are claiming, if it is true, then I can able to purchase. I can able to take this 500 laptops and I can able to sell this. So he just thought like that. So he don't know statistics. So he just asked me. So Sumanth, can you just help me to to decide whether to buy these laptops or not? So I just said that okay, we can just do it, right? So this is just an example, right? So I hope it will be an interactive one. So that's why I'm just explaining this. So what I have did is, so they're just having laptops, right? So they're having a laptops, say somewhere around like 5,000 to 10,000 laptops they just have in the company. So in that, for our test, like to test, I have taken around 40 laptops. In SAM, I just taken around 40 laptops, and for these 40 laptops, I've just calculated the mean, like what's the average battery life. So I just got around 17 hours. For these 40 laptops, I just got the 17 hours as the average battery life, and with a standard deviation, of 2, right? The deviation between the values is 2. So yeah, that's fine. Now to perform the Z test, first step what I have done is I will just assume the null hypothesis and alternate hypothesis, right? So we will just try to assume. First I just assume that null hypothesis. I just defined the null hypothesis and alternate hypothesis. So what we should assume in null hypothesis, right? So everything is equal. There is no difference, right? We used to assume these kind of statements in null hypothesis. In the same way, I'm just assuming that in null hypothesis, the mean battery life, the average battery life is greater than or equal to 18, right? I just assumed that like what they just mentioned, right? It should be equal to 18, or let's say even if it is greater than 18, that's nothing issue, right? That's good for us. So I just assumed that mu is greater than or equal to 18. And in alternate hypothesis, I just assume the mean mu is less than 18. So that's the first step is I just assume the null hypothesis and alternate hypothesis. Now we will just define the parameter. The population mean is 18. So the population mean is on the entire laptops what they just mentioned, right? What the company have mentioned. They just said that 18 hours battery life for the entire laptops. And this, what's the sample mean? Sample mean what, like we just taken a sample, and for that what's the mean? 17. And what is the sample standard deviation? Is 2, right? We just got 2. And what's the sample size? How many samples we just taken? Like like in each sample, what's the number of laptops we just taken? 40, right? So that's what the parameters I've just defined. And next step what I'm just assuming is defining the significance level. So if you just watch my video on p-value, so I've just explained what is the significance level, how to choose significance level, what's the meaning of significance level, right? I've just discussed everything. So yeah, make sure to watch that video before that. Yeah, that's fine. So so what I did is, and next step, I've just assumed the significance level, right? I just assumed alpha is equal to 0.05. So I just defined the alpha is equal to 0.05. And in third step, what I just did is I just started performing the Z test. So what's the formula to calculate the Z test? X bar minus mu divided by S divided by root n. So this is the formula for Z test. We will just try to understand, right? Now before that, you just want to understand what is rejection region here, right? I just want to explain you that. So this is the standard normal distribution, and this is the mean mu. So since standard normal distribution, mu will be 0. Mu is equal to 0. Now so if you just watch our previous slide, the H1, the alternate hypothesis is mu is less than 18, right? So we have to, since it is less than 18, so it is on the left side, we just want to perform left tail test. if it is mu is greater than 18, we will just perform a right tail test. And if mu is not equal to 18, right, if you just explain, if you just say that mu is not equal to 18, then we should we will just perform two tail test. So that's what you that's what you should remember here. And you can see, since it is a mu is less than 18, we will just only perform a left tail test. So let's take left tail test, right? We used to perform only left tail. And if mu is right, I will just explain you other tests as well. So if mu is greater than 18, then we used to perform a right tail test. If mu is not equal to 18, then we used to perform two tail test. So we used to two tail means we used to consider both left and right. So that's the difference between the tests we just have, like the left tail, right tail, and two tail test. Now in our example, we just have mu is less than 18. So we used to take the mu is less than 18 means left tail test. So we have to find what the significance level we just assume. Alpha is equal to 0.05. So for this alpha is equal to 0.05, we should find the z value. So I just said you, right, if it is a standard normal distribution, all the points are z scores. If it is a normal distribution, then it will be points, but here it is a standard normal distribution. We should find the z values, z scores. So what's the z value for the 0.05? We will just we can able to find this using z table. This is the z table. So what's the value we just want to find? 0.05, right? So where is 0. So here you can see these are the z values. Like these are the z values, right? And now where is 0.05? So just find 0.05. So you can see we can't find any 0.05 here. It means this is the z table for the right hand side. So we can see this is the standard normal distribution, right? For right hand side, we used to have one z table, and for the left hand side, we used to have other z table. So this is the z table for the right side. Now let's try to find the let's check the other z table. So this is the other z table here, and now you can see 0.05, right? So you can see here here you can see we just have 0.05, right? Minus 0.05. So what's the corresponding value for this? So you can see it is minus 1.6, and on the column wise it is 0.4, right? So for 0.05, the z value is minus 1.64. So this is the z value. So this is the z value, right? This is how you can find the z value, right? This is minus 1.64, right? You can see minus 1.64. So similarly, if you want to find the z value of the right hand side, right? If you just want to find this area, so you can see here this, right? If we are performing a right tail test, if you want to perform this, like if you want to calculate this, you can just check the previous table, like the table which is corresponding to the right hand side. So you can just check the table and you can find the z value. And if it is a two tail test, so how you can just find the z value is, so if it is since it is since if it is a two tail test, 0.05 divided by 2, it means here we should calculate the z value for 0.025, and similarly this side it will be 0.025, right? If it is a two tail test, we used to divide this 0.05 by 2. If it is a right tail test or left tail test, we used to find the z value for the 0.05. So that's what you just want to understand. So if you have any kind of doubts regarding this, make sure to comment down below. Now this is the z value, right? This is the z value for the 0.05. If we if the value which we just if we just perform this z test, and if it is here, if it is fall in this region, then we will just reject the null hypothesis. If it is if the value is here, if we just fall in this region, we will not reject the null hypothesis, right? So that's how we used to perform. Now let's try to find the z test. We will just calculate this. Now the sample mean is 17 minus the population mean is 18 and divided by what's the standard deviation of the sample, right? What's the standard deviation of the sample? It's 2 divided by root 40. So if you just calculate, the output will be minus 2.8, right? You will get the output as minus 2.8. Now minus 2.8, where it will lie? So it will lie in the rejection region. So it will lie somewhere around here, right? Minus 2.8. So it is falling. So the Z value which we just calculated, it is falling under the rejection region. So we will just try to reject the null hypothesis. So what's the null hypothesis? The null hypothesis, mu is greater than or equal to 18. So what they just specified, right? The company specified that the mean average battery life is greater than or equal to 18. So with 90, so since the alpha is equal to 0.05, we can just say that with 95% confidence, with 95% confident, we can reject the null hypothesis. We can just say that this statement is wrong. Mu is not greater than or equal to 18. Mu is less than 18. So we can just take this, right? So that's how you can just perform this Z test. And if you just watch my video of p-value, I just said that we will just calculate the p-value using the Z test, and if p-value is less than 0.05 or let's say p-value greater than the 0.05, we will just able to reject the null hypothesis, or let's say fail to reject null hypothesis. I just said you like that, right? So this is one way. We can just find, we can able to reject the null hypothesis. Like we can find the Z value for the 0.05. So if minus 2.8 falls under this, then we will just reject. And the other method is, so what we just got, by performing the Z test, we just got minus 2.8, right? We just got minus 2.8. For minus 2.8, what's the value in the Z table? So this is the Z value. Z is equal to minus 2.8. So corresponding to minus 2.8, what is the value in the Z table? So we can just find, right? So minus 2.8. So you can see here, you can find, right? This is the Z table. So this is minus, so you can see here, we just have minus 2, and minus 2.8 means we just have here. So this is the value 0.0188. So p value will be 0.0188, right? So this is the p value. Now what I just said, if p value is less than alpha, we will reject the null hypothesis. So you can see alpha is equal to 0.05. So 0.01 is less than 0.05, right? This is true. So we will just reject the null hypothesis. So what I'm just saying here is, we can able to do either of the two methods. So the first method which I just specified here, like you can able to find the Z value of the alpha, and if the value which we just got in the test, if it is in the rejection region, we can able to reject the null hypothesis. Or let's say this minus 2.8, for the minus 2.8, you can just find the p value using the Z table, and if that p value is less than alpha, we can just reject the null hypothesis. So these are the two ways we just have like to perform this hypothesis testing. So that's about this Z test, right? I hope this video is helpful for you. I hope this video is clear. So nothing that you don't understood. Like I hope you understood everything about this Z test, like how to perform Z test, and like how to calculate the Z value, how to look at the Z table, right? How to calculate the p value, how to calculate the Z value, right? I hope you got everything about this Z test. So yeah, if you feel so, like if you feel this video is helpful, make sure to subscribe to the channel and also like this video, and also I will just create such kind of amazing content in this channel. So make sure to subscribe subscribe to the channel. So with that, if you have any kind of doubts, make sure to mention in the comment section. I will just try to clear that. So yeah, that's all for this video, and yeah, I will see you in the next video. Until then, take care.